Alright, seniors. For those of you who were here last week, Tuesday, I gave you an activity where you were finding the derivative and then finding the derivative of a derivative. That is called higher order derivatives, which we're doing today. So today is the 11th. We are working on higher order derivatives. Higher order derivatives. Jaime, can you turn off the middle light? I gave you all a worksheet with the examples for today, the practice, and then on the back you'll see the scale and what each problem will look like approximately and the expectations. Does everybody have one? So today we're working on level 2. You'll have an exit ticket after you do practice. It is a 2-question exit ticket. Level 2 will be polynomials or special functions level 2. So you're only going to have problems that look like this or problems that look like this with special functions. So sine, cosine, natural log, e to the x. Keep in mind these are only examples. I can't write all the ways that you can see the problem. These are just 2 examples. Level 3 we'll work on tomorrow, and level 4 will be during a pause day. Delilah? Okay. Expectations for level 2 are that you're using correct notation because we do have 2 standards. The standards for the notation is 1 standard, so this will be 1 standard you're tested on, which is Fun 3F.2. And then the actual derivative will be another 3F.1. I don't remember what I named it. It's on the board. Thank you. Did you get one of these? No? Okay, check up right here. So you have 2 standards on all your exit tickets for and assessments for these things, okay? Notation and actual derivative. Are there any questions before I go? Okay, so again, these are higher order derivatives. Your first level 2 will be fairly easy. It's not as rigorous. It's just taking the double derivative. So the derivative of the derivative and then the third derivative. So one more time. So we need some vocabulary and notation. Can you see that? Or do I need to make it darker? I'm sorry? Darker? Yeah. Okay. That? What'd you say? Or this way?
I thought you meant like the lights.
Oh, no. I need to keep them on. So what we've been working on only is the first derivative. Maite, this is not in the PowerPoint, so you're going to have to write this one down, okay? The first derivative is the slope of the tangent line of a function or graph, okay? We will need to remember this in the next couple of weeks because it matters. We have been using the notation f prime of x or dy dx or y prime. These are all the notations for the first derivative. So remember, depending on what we have, if we have a function, we use this. If we have an equation, we use these two. So this is for equations. And this is for a function. Remember, you cannot interchange the two. So if you start with a function, your derivative notation has to be in function notation. If you have an equation, it has to be an equation notation. Hey, that rhymed. Next, we have the second derivative. The second derivative is the derivative of the first derivative. That's why it's called the second. Is the second time we are taking the derivative. It's the second time we're applying the derivative rules. That notation is f double prime of x. So f double prime of x, okay? D squared y by dx squared, meaning this is the second derivative of y with respect to x. Second derivative of y with respect to x. Or y double prime. Again, these cannot be interchanged. If you start with a function, you have to use function notation. If you start with an equation, you need to use equation notation. Again, rhymed. You cannot switch between the two. Questions so far? I know it's just all vocabulary and all notation, but it's really important that you understand.
What do you mean by, why do they say equation?
So remember, you're going to have problems that look like y equals, right? Or f of x equals. If it is in y equals notation, it has to be this, which is an equation, right?
Oh, you're just saying y and the dx are like the same?
Yes, yes. You can use either of these two notations.
Okay.
Okay? Does that make sense now?
Yes.
Okay. Oops, I wrote it backwards. Okay. All right. Higher order derivatives. Oops, I spelled wrong. Order. Are any derivatives past the first? So the second derivative is technically a higher order derivative, but we have specific notation for those two things. Okay? We have specific notation for double derivative and triple derivative. We have specific notation for those that are greater than 3. So the notation for higher than second is as follows. I hope I can fit it on here. Fn of x, and then dny dxn, where n is the nth derivative. I'm gonna have to write on another piece of paper. That sucks. So for example, if it's the fourth derivative, it will be f fourth derivative of x, or d4y dx to the fourth. These are the only two you can use if it's greater than 2. I'm sorry, greater than 3.
But if n is the what?
Hold on.
Oh, you're going
Where n is the nth derivative. So like 4th derivative, 6th derivative. Okay? That makes sense?
to. Yeah. So, yeah.
Got it? So this would be the 4th derivative. We cannot do, in this example, y to the 4th, because this is an exponent. We cannot do y to the 4th because of the exponents, okay? Oh, I'm sorry, this should be greater than 2. I was right. Greater than 2, not 3. When you're done writing that down, take out your notebook or that sheet that I gave you so I can do the examples and show you what I mean by all of this. Yeah. Okay. Bere. Kevin, ready? You guys ready? Okay. So let's look at the first example. The first example, the directions tell us to find the second and third derivative of the problem. So here is our first thing. We need to, before we find the second derivative, we need to find the first derivative. Before we find the third derivative, we need to find the second. So it has to go in a pattern, in order. What rule am I going to use for this? For number 1. Power rule. So I'm just using power rule. If you need help with power rule, please make sure you're coming to office hours. So the power rule, remember, we're just multiplying the coefficient and the exponent and subtracting 1 from the exponent. And that gives me 27x squared minus 14x minus 9. Remember, if it is a linear term, it is just the coefficient, and if it is a constant, it goes away. Any questions on the first derivative? If you stop here, you will get zeros. This is not even the second derivative. This is only the first derivative.
Oh, you have to do the 27 by 2?
Yeah.
Oh, it's like that.
So this is not even an answer. Like, you would get 0 credit for this because the directions say find the second and third derivative. So like Walter said, we need to multiply the 27 times 2 and then subtract the 1. So we're applying the power rule again. So f double prime of x, again, I need to make sure that I have correct notation because these two things are not the same. 54x minus 14. Did I do that right?
Yes.
Thank you. Thank you, thank you. On the test, if you stop here, on the assessment, or on the exit ticket, if you stop here, you will get 1 point because you have not done the third derivative. You have to make sure you're following along. Yeah.
What's those quotation marks called?
That's not quotation marks. They're like apostrophes. And it's kind of like prime. I don't know what
They call it.
Prime.
prime. So this would be we'd say f double prime.
Oh, double.
Or we can say the second derivative of f. Okay? Good question. But we're not done because we need to take the third derivative. So here is where you can't do the triple dashes. I mean, you can, but I mean, it just doesn't look right. So you just put the 3 to show that this is the third derivative. You'll just put the 3 to show that this is the third derivative. And the derivative is 54. So here's your third derivative, and then you're done.
And that's a 2.
This is a 2, yes, and it is a 2 because you have the derivatives correct. So that's one standard, and then the other standard, your notation is correct. So that is also a 2. So you get standard grade for the notation, grade for the derivative. Yes.
Instead of the lines, can you just put a 2?
Instead of the lines, can you put a 2?
It's the same thing.
Yeah, that's fine. That's fine. I'm fine with that. Just know though, I will be putting probably the double, so you know what that is, okay? Questions on that example? Seniors, good? No, yes? Good? Okay, can I go down? Right there? Okay, second example. 12 cosine? Okay. Sometimes it does. The directions here also tell me to find the second and third derivative. Okay? Remember that the derivative of cosine is negative sign, but we have a coefficient here, so what's it going to do? Change it to what? A negative sign. So it will be y prime or dy dx. Either one is fine. I don't care which one you do. So it's going to be negative 12 sine x. If you don't have these memorized, where are they? In the orange bin if you don't have your own copy of the derivatives. Are you done?
No.
Who said yes? No, you're not done. What is this only? What is this the only thing of?
The first derivative.
This is the first derivative. Have I even answered the question? No. This is only the first derivative. So I'm going to have to take the double derivative. And it's going to go back to cosine. Does the negative change?
No, it stays the same.
Stays the same. So this is the second derivative. Questions?
Wait, can you do y3?
No, that's why I said you can't do y3. This one you can also do, let me write the other one down that you can do. You can do d squared y dx squared. So you can do this or this. This or this. Either one. So, third derivative now. What is the derivative of cosine? Just sine?
12 sine x.
This is 12 sine x. So remember that we need to convert back to the positive. Now, this is where in the 13 years I have been teaching, students still do this. As Walter said, do not put y cubed. Don't put y3 because that implies that it is cubed. So you will need to do d cubed y dx cubed. What'd you say? Mm-hmm. So this is why I was trying to get you guys to get in the habit of doing dy dx. Questions? What is the derivative of cosine? What kind of sine? So remember that, so if we have negative a cosine x, right? No, sorry. If we have cosine x, the derivative is negative a sine. Okay? So that means it's going to switch the coefficient. So if it's negative, it becomes positive then. If it's positive, it becomes negative. Got it? That's like up here, it became negative. So you just have to switch back. Okay? Questions? Are we sure? We sure we're sure? Okay.